Hi, my name is Judy, and I'll be covering chapter 24 about metabolism. So, beginning with nutrition, there are different groups. So, starting with carbohydrates, the sources of carbohydrates can be found from plants, starches, sugars, and fibers. The functions include the burning of glucose to make ATP, so energy for the body. The dietary requirements, it is recommended that it should only be a 45 to 65% of the total caloric intake. They're complex versus the simple carbohydrates. Complex, which are good ones, and then examples of those include whole grain and vegetables, while simple carbohydrates are bad, such as sugars or sodas. Then moving on to proteins, sources of that can be found in meat, fish, nuts, and eggs. The functions of proteins, there are rules starting with the all or none rule, where the amino acids must be present, all of them, or the proteins can't be made. And then there's also the caloric intake, which states that diet must supply enough carbohydrates to make the ATP, and if not, then the tissue proteins are used as fuel. Then there's also the nitrogen balance, which explains the rate of protein synthesis equals the rate of protein loss. And then the anabolic hormones, which accelerate the protein synthesis and growth. The dietary requirements for proteins is 12 to 20% of a person's diet. And then there's two groups of proteins, the complete versus incomplete. Complete are substances that contain all 20 essential amino acids, while the incomplete have only some amino acids. Then there's the lipids. The sources can come from animal products, which are saturated, and then plant sources, which are unsaturated. Functions of lipids include being an insulating layer under the skin, an easy way to use fat for energy. Then the triglycerides fuel skeletal muscles, and fats help absorb fat-soluble vitamins. And then the dietary requirements for lipids should be around 40% of the total caloric intake, where 30% is saturated and 10% is unsaturated. And then next is vitamins, which are split into fat soluble and water soluble. Fat soluble includes vitamins A, D, E, and K, which binds with lipids. And then water soluble, which include B complex and C, which bind to intrinsic factor to be absorbed with water in the GI tract. Next is the minerals group, which are split up into the moderate and trace amounts needed. So the moderate amounts needed include sodium, potassium, calcium, chloride, magnesium, phosphorus, and sulfur. And then the trace amounts are iron, iodine, magnesium, zinc, copper, cobalt, fluorine, selenium, and chromium. So minerals are not used to fuel the body, but it works with other components to ensure functional units in the body. And next, the metabolism part of the chapter, starting with metabolism processes. Catabolism is the breakdown of large structures into small ones. The anabolism is reactions that build large molecules from small ones. And oxidation reduction reaction is are reactions that include oxidation and reduction. So the oxidized part of the reaction loses electrons, while the reduced gains electrons. Then there's ATP synthesis, which there are two types of: the substrate level phosphorylation and the oxidative phosphorylation. The first, which is the substrate level, is where the ADP reacts with the phosphate and forms ATP from the help of an enzyme, while the oxidative is through the electron transport chain. Next is the carbohydrate metabolism, the oxidation of glucose. So there are different steps and processes, starting with the glycolysis, which activates the sugars and then cuts it up into carbon pieces. Then it oxidizes the carbon pieces and reduces the NAD ion to NADH and a hydrogen ion, and forms 2 pyruvic acids, 4 ATPs, and then finally with netting 2 ATPs. So in the absence of oxygen, pyruvic acid forms into lactic acid, but when O2 is available, it is turned into pyruvic acid, which enters the Krebs cycle. Entering the Krebs cycle next, the decarboxylation of pyruvic acid occurs when, which in turn releases the carbon dioxide. The oxidation is when the hydrogen ion is taken up by the NAD positive, and then acetic acid is formed. Then when acetic acid binds to coenzyme A, it forms acetyl-CoA and then turns into the Krebs cycle. Then in the Krebs cycles, it forms 3 carbon dioxides, 1 ATP, and 5 reduced coenzymes. There are 2 pyruvic acids produced from each glucose molecules. And then the reduced coenzymes carry their high energy electrons to the electron transport chain, which then there are chain components that are proteins bound to metal atoms, which include the flavins and cytochromes. And then the respiratory enzyme complexes pass electrons along to lower energy levels until given to an oxygen molecule, and then water is formed. So then electronic energy carried by electrons is used to transport the hydrogen ion into membrane space, which creates the electrochemical proton gradient, and then that stores potential energy used to make ATP later on. And then in the ATP synapses, it uses the energy from the flow of electrons to add a higher level phosphate to ADP, forming ATP. And then each pyruvic acid that goes into the electronic chain, transport chain, forms 10 to 11 ATPs. So the final total products equal up to the 32 ATPs, the 6 hydrogens, the 6 water molecules, and 6 carbon dioxide. And then the heat, 40% of the energy in the glucose is used to form ATP, and then the 60% is lost as heat. And then so there are a couple of terms. The glycogenesis is just the production of glycogen through binding of glucose molecules. The glycogenolysis is the breakdown of glycogen, and then the gluconeogenesis is the production of glucose from substances that were not glucose prior. And then next is the lipid metabolism. The lipid metabolism, so oxidation of glycerol and fatty acids. So it comes from the beta oxidation. The fatty acids oxidation, which occurs in the mitochondria. The products of the fatty acids are 2 carbon acetic acid molecules, while NAD and FAD are reduced, which are coenzymes. So the lipogenesis is the production of fat, while lipolysis is the breakdown of fats. The ketogenesis is when fatty acids and ketogenic amino acids are burned to form ketone bodies, which are alternative ways to fuel the body when glucose is low. Then there is the synthesis of structural materials, the membranes, which are made up of phospholipids and cholesterol, the myelin sheath, which is made of phospholipids, the lipoproteins made to transport cholesterol, fats, and other molecules. The thromboplastin is a plasma protein that helps clot blood through the formation of thrombin. And then the cholesterol is used to synthesize steroid hormones, bile salts, and acetylcholine. Next is the protein metabolism. Oxidation of amino acids, so the transamination converts an alpha ketogluteric acid to a glutamic acid, and then the oxidative deamination, it includes the amine group is removed to form a ammonia molecule. So the ammonia molecule reacts with the carbon dioxide through the urea cycle, which produces urea and water, which is urea is just excreted from the body as urine, and then the keto acid modification forms pyruvic acid, acetyl-CoA, and alpha ketogluteric acid and oxaloacetic acid that enters the Krebs cycle. The amino acids that are used to produce pyruvic acid can be reused to form glucose, hence gluconeogenesis. And then protein synthesis, amino acid is just the foundation of the synthesis of protein. Next is catabolic-anabolic steady state. So the base and steady rate of catabolic and anabolic reactions, substances are being broken down and formed at the same rate. The nutrient pool is the available amino acids, carbohydrates, and fats. And then the amino acid pool is the entire supply of amino acids in the body. The absorptive and post-absorptive states, events and controls. So the absorptive state is during and after eating, when the anabolism rates are higher than the catabolism, and nutrient groups and their destinies. So carbohydrates are monosaccharides forming into glucose, fructose, and galactose, which are transformed into glucose, which is then converted into glycogen. Then there is triglycerides, which are the chylomicrons, are broken down to fatty acids and glycerol, which is stored in muscle and fat tissues. Adipose, skeletal, cardiac, and liver cells all use this as a primary energy source. And then there's the amino acids, where it is sent to the liver and is used for the production of ATP or stored as fat in the liver. It also makes plasma, it clots blood, and transport proteins. Then the hormonal control, insulin is essential to all phases of the absorptive state. So diabetes mellitus is just another name for diabetes in this case. And then post-absorptive state is when you fast. Sources of blood glucose, so the glyconeogenesis, neolysis in the liver is the first source of glycogen, and then the glycogenolysis in the skeletal muscle is a secondary source. So after energy is burned from the liver, the body then burns energy from the muscle. Lipolysis is in the liver, and adipose tissue is a breakdown of fats. And then glucose sparing is just stating that the use of proteins and fats for energy to save glucose in the body. Controls, hormonal, glucagon is released when blood glucose levels decrease, and while in the neural section, the sympathetic nervous system includes the adipose tissue in the body that contains fibers that release epinephrine and aids glycogenolysis. Then the role of liver in the metabolism. So general metabolic functions, it breaks down fats and provides the energy for the body. Cholesterol metabolism and regulation of plasma cholesterol levels. There are different lipoproteins, which are to transport fats by mixing fat-soluble proteins. So they're the high-density ones, which are good cholesterol, which transport transport excess cholesterol from tissue to liver. The low density, which is bad cholesterol, which carry cholesterols to tissues. And then there's the very low density proteins, which transport lipids to adipose tissue and drop off triglycerides and then become the low density lipoproteins. And then there's the chylomicrons, which transport lipids and molecules from the GI tract. Regulation of the plasma protein levels, the plasma cholesterol levels, saturated fats increase the liver's production of fat cells, while unsaturated increases cholesterol. So next, the final section is body energy balance. So the regulation of food intake, nutrients signal related to energy stores. Glucose, amino acid, and fatty acid levels send signals to brain that regulate the energy input and the output. Increases glucose levels causes decreased eating, while fasting the signal is turned off and makes the body hungry. So increase in amino acids weakens the urge to eat, and then the increase of fatty acids leads to a decrease in eating. The hormones insulin and cholecystokinin is released during food absorption and inhibits the hunger, while epinephrine and glucagon stimulates hunger. And then the body temperature, it rises and falls with the BMR, the basal metabolic rate. So the metabolic rate and heat production has a few definitions. So the metabolic rate is just the energy output that can be measured by a respirometer or a calorimeter. The basal metabolic rate, which is the BMR is the energy that is burned while resting. And then the total metabolic rate is just the energy of all body activity. And then the factors influence BMR are age, gender, stress, and hormones. And then the factors influencing TMR are is the intake of food. So when it increases, the TMR increases as well. And then clinical problems include hyperthyroidism, is when there's an increase in the BMR. And then the hypothyroidism is a decrease of BMR. And then regulation of body temperature. So the core temperature is the highest, while the shell temperature is the lowest. And the core is located in organs in the skull, the thoracic and abdominal cavity, while the shell is just the skin on your body. And then mechanisms of heat exchange. So radiation is the loss of heat in the form of infrared waves. Conduction is the transfer of heat from a warmer object to a cooler one directly. And then convection is the movement of warm air and cool air, which the warm air rises up and the cool air falls. And then evaporation is when water molecules heat up and changes from a liquid to gas phase. And then the insensible water and heat loss is just lost through evaporation on skin or lungs. And then the role of the hypothalamus, it controls the thermoregulator centers. So it consists in heat loss center when the body temperature rises above average, and the heat promoting center when the temperature drops below average. The afferent input, which includes the peripheral thermoreceptors, which are in the skin, and then the central thermoreceptors, which is the body core. The heat promoting mechanisms dilate blood vessels and induces sweat, while the heat loss mechanisms include constriction of the blood vessel, shivering, an increase in the metabolic rate, and increases thyroxine. While fever is a technically controlled hyperthermia. It's caused by infections of the body, so the body raises the temperature. And then the last clinical problem is hypothermia. It's just the heat stroke when the body's temperature raises beyond the average temperature. And that is it.